Okay, so this is 4-2. Today we are going to multiply and divide radicals. And on the first page, I'm just going to do 8, 12, 15, and 16. This is kind of like yesterday's, except I have 2 radicals. So before I do what I did yesterday, I have to make it into 1 first, and then I do what I did yesterday. So to make this into 1, I'm going to have the cube root 50 times 15. Now instead of multiplying that together, I'm just going to put 50 times 15. And then when I multiply with exponents, I add them. So I have z squared, y cubed, and then I have z to the 5th and z to the 1st. That would be z to the 6th. Okay, so what I'm going to do is I'm going to break these down. So 50 is 2 and 25. 25 is 5 and 5. And 15 is 3 and 5. Okay, let me go ahead and bring down my cube root. I need 3 of the same number. Looks like I've got 3 5s, which means I'm going to bring out a 5. I'm left with a 2 and a 3 underneath. So I multiply those together to get 6. Now I'm going to look at my variables and divide my exponents. Well, 3 cannot go into 2, so x squared stays underneath. 3 goes into 3 exactly 1 time, so I'm going to bring out 1y. And 3 goes into 6 exactly 2 times, so I'm going to bring out a z squared. This looks kind of messy, so I'm going to rewrite it. So 5y z squared, and then I have the cube root of 6x squared. So this is my answer to number 8. All right, number 12. So I'll do 12 over here. So first I want to combine this into 1 radical. So I'm going to take 2 times 4. Now this time they're smaller numbers, so I'm going to go ahead and multiply those together. I just didn't do that over here because I was going to backtrack. I was going to do 50 times 15 and I was going to break that number up. Okay, so then I'm going to add my exponents. So x cubed and y to the 9th. Okay, so I'm going to break down the 8. That's going to be 2 times 4. And then 4 is 2 and 2. I need 3 of the same number. I got 3 2's, so I'm going to bring out that 2. I don't have any numbers left underneath, so let's go to our variables now. I'm going to divide our exponents. 3 goes into 3 exactly 1 time, so I'm going to bring out 1x. 3 goes into 9 exactly 3 times, so I'm going to bring out a 3. There's nothing left under the radical, which means the radical just goes away, and 2xy cubed is just my answer. So this is my answer to 12. Okay. You know what, I'm going to cross off 15 also and just do 16. I think that'll be plenty. This time I have numbers on the outside, so I'm going to multiply the numbers on the outside together and then multiply the numbers on the inside together. However, if I do 15 times 18 and get one number, those will just break up into 15 times 18 anyway. So I'm just going to leave it as 15 times 18. And I'm going to break these down. This is 3 times 5. This is 3 times 6. And this is 3 times 2. Notice I don't have any exponents, so I don't have to divide anything. So I need 3 of the same number. So I got 3 3's. So I'm going to bring out that 3 with the negative 6. So far I have negative 18 on the outside, and then I have a 5 and the 2 on the inside that I'm going to multiply together. So this is what I should get to number 16. Okay, that's multiplication. Now let's go to division. Yes, I think this is the last page of 4-2. Yeah. Okay, division. Okay, so number 20. The first thing I want to do is maybe separate that into two separate radicals. So I'm going to rewrite this as the square root of 20 divided by the square root of 49. 49 happens to be a perfect square, so now I just have that. Now 20 is not a perfect square, but I can simplify it. I'm going to break it down. So 20 breaks down to 4 and 5, and then 4 breaks down to 2 and 2. Now since I don't have a root index, I'm looking for 2 of the same number, which I have. So the 2 is going to come out in front, and the 5 is going to stay underneath. And again, that's all divided by 7. So that's my answer to 20. And we did this before back in chapter 2. We also did something like number 21 in chapter 2. So let's go to that one. I cannot have any radicals in the denominator. So whatever I can't have, that's what I'm going to multiply both top and bottom by. And then I just multiply straight across. I can't multiply 2 and 5 because one's a number, one's a radical. I can multiply these two 5s together because they're both under the radical. That's going to give me the square root of 25, which turns out to be just 5. So there's number 21. Okay, starting now, this is the new stuff. I kind of mentioned this back on the notes from 4-1. I cannot have a radical in the denominator. I want it to turn out to be just x. Whatever my base is, that's what I want it to be. So what I need to do is figure out, I still have the 4th root. I have to think, how many more x's do I need? How many 4th root of x's do I need to get just x? I need 4 of these total. So since I only have 1, I need 3 more. So x cubed and x cubed. So 1 times this, it's just the 4th root of x cubed. And that is my final answer. Now these can be a little tricky, so if you need to rewind and listen to what I said, go for it. But I'm going to move on, so you can always pause and replay me and fast forward and all that good stuff. Okay, so I'm going to multiply by a fraction, and I'm going to end up with a fraction. The denominator that you're going to end up with is always one of each of the bases. So I'm going to end up with a 2, an x, and a y. I don't care about the numerator yet. I don't care about that right there. I only care about the denominator. I have got the cube root. In order for me to get this, I need, well, currently I have 1, 2. I need 2 more to get 3 total. I have 2 x's. I need 3. I need 1 more x to get 3. I have 1 y. I need 3. I need 2 more. Okay, so I'm going to take 3. I can't multiply 3 by anything under here because it's outside. And then I've got the cube root. This becomes 4. And then x, y squared. That is my answer. Okay, last one. I'm going to split this up like I did back on 20. Okay, I'm going to multiply by a fraction. I'm going to get a fraction back. I'm going to end up down here with one of each of my bases. So a 4, a b, and a c. One of each. Okay, Okay, I got the cube root again. I got 1 4, 2 b's, and 1 c. I need 3 of each. I have 1 4. Well, I need 2 more to get a total of 3. I have 2 b's. I need 1 more b to get 3. I have 1 c. I need 2 more to get 3. All right, now I'm going to multiply my numerators together. But I don't think I'm going to have enough room, so let me rewrite this. Okay, so I just rewrote this. I moved it down there. 4 squared is 16 times 3. 16 times 3. 48. Yep, 48. And then I have an a, b, c squared. Now, you have to check to see if you can reduce 48. So far, I haven't been able to do that, but 48 might be able to simplify. So off to the side here, I'm going to see if I can simplify the cube root of 48. I think I'm going to be able to. So 6 and 8, 3 and 2, 2 and 4, 2 and 2. Okay, I need 3 of the same number. I got 3 2's. So I'm going to bring a 2 out. I have a 3 and a 2 left over. That becomes a 6. And then I still have ABC squared. And then I still have my denominator that's the same. And there's actually one more thing I can do. Since this 2 and this 4 are not under radicals, I can reduce that. This becomes 1/2. So this would be my final answer. So that is for 2, multiplying and dividing radicals.